So this is the second video in the series of Rust by Practice, where we solve programs and learn Rust programming language. Today we are going to start basic types, and the first one among them is integers. Because Rust is a systems programming language, we have to have more granular system of types. In the first exercise, it asks us to remove something to make this code work. We are creating a variable x, which is a signed 32-bit integer with a value 5, and y is being created as a mutable variable. That is, we can change the value of y, and we are giving it a type of unsigned 32-bit integer. That is, we cannot store a negative integer in y. In the next statement, we are inserting the value of x into y, or we are assigning the value x to y, which is something you would find problematic because they have mismatched types. It shouldn't be happening. Now let's try to run it before we actually fix this program and see what is the error, because we should also be familiar with what kind of errors we can get. So as expected, it says that we have a i32-bit, but we expect a u32 type value. So let's remove this line to fix this code and run it. It should print success. Yes, and the next thing that this exercise is also asking is the type of Z. We are not specifying it. Rust actually infers it automatically, but what is that type that it by default infers? It is going to be i32-bit by default. This is what Rust infers. So let's write here that it would be assigned 32-bit. So let's move on to the next exercise. We have to fill in the blank. So let's try to understand this. What we are doing is creating a variable v with a type of unsigned 16-bit, and we are storing 38 here, but 38 is an unsigned 8-bit integer. So this is really important. We can actually do this. If you know C or C++, you know that we can actually do in C++ something like long and something like this to make it a long value. Similarly, in Rust, we can specify the type of a value by an underscore and followed by the type. Now, but we need a u16 in order to make this code work. So what we will do is we will convert this u8 value, that is unsigned 8-bit integer value, to an unsigned 16-bit integer. This is going to fix the code, and let's run it, and it worked fine. So to revise it, this is going to get converted to a u16. It's similar to casting in C++, where we convert one type into another. The next exercise is we have to modify this assert. Let's run it first, and then we will try to understand it. So this assert is actually failing. It's saying that left is not equal to right. Left is u32, all right. Left is u32, that is correct, but right is i32-bit. So let's try to understand this code. We are making a variable x, and we are giving it a value of 5, and previously just now we studied that by default Rust will infer the type to be i32-bit, and we are comparing it with u32. So if you try to understand this code, we are asking for the type of x. We are not going into detail of what is this ampersand and what is this dangerous looking code, but just try to understand it at the very basic level, that this is trying to get the type of x, which is going to be i32, and which is obviously going to fail because we are comparing it with u32. So in order to fix this code, we should change this to I and run this code. It prints success. Now, just to give you a little bit of an overview of this code, here type of is a function, and we are using generics. I know if you are familiar with programming, I'm pretty sure you know what generics are. We are accepting basically any type of argument, and we are returning a string. We need a string because we are comparing it with a string. So this function is returning a string. Any statement that is not followed by a semicolon is by default considered to be a return statement by Rust. This is very important. If you see something like this without a semicolon, that is the last line of the function without a semicolon, then it is the return statement. So it's something like return format. Now, format is a macro. Again, it's something new that we will study afterwards. I don't know when it will come. Somewhere here at the very end of this. So let's reserve that for that time. But just to give a little bit of an idea, it is going to just return a formatted string here. Okay, because we want a string to be returned. And that is pretty much for this exercise. Let's move on to the next exercise, which is asserting the value of i8 max with some value that we have to put. Now, if you know a little bit of mathematics here or something about memory, then you know that i8 will go at max to 127 value. So the range of I is, to the best of my knowledge, minus 128 to 127. Let's try to check it. 127, and try to run it. This should pass, but this should fail, and we should get an error for this. Yes, so I was right. So the max value of i8 is 127, and for unsigned 8-bit integer, this is going to be 255, not 256. 255 because 0 is also included. So if we count from 0 to 255, it is going to be 256 numbers in total. So let's print, and yes, it prints success. So let's call it a day. We will continue this exercise in the next video.